Alexandra, who's going to talk to us about mobile testing for grown-ups, and I just had a little preview of it. I'm sure it's going to be excellent. So everybody welcome Alexandra.
Hi, my name is Alexandra. It's my first time in Portland. It's very exciting to be here. I come from Romania, where, contrary to popular belief, we don't sparkle during sunlight. My talk today is inspired by a conundrum I often get into, and that is when starting a new project, I have absolutely no idea where to start making sense of it. So do I look at the solution? Do I look at unit tests? And if I'm lucky, I'll have unit tests. And one thing that has worked for me until now is behavior-driven development, which kind of puts a friendly face on development. And as a reminder, behavior-driven development is a style of outside-in programming in which the application code is written only after its requirements have been defined. Its purpose is to be a collaboration tool where you sit down with your client and work together. And you're basically discussing examples of what the app would do, how it should behave, in order to get to a common ground, have everybody on the same page, and using a language everyone can understand. So not only developers, but also testers, business people, project managers, and so on. At the end of this process, you get concrete, executable, easy-to-repeat behavior that will live inside your tests, which can be automated if you'd like. And the great thing about this is that you get a live documentation, which changes when you change your code. So no longer someone who barely knows the product writes a documentation that is outdated by the next sprint. You're pretty much doing yourself a favor, and you're creating a nice space for people to get onboarded quickly when they come to the project. In order to start this process, you need to find out what the user really wants. You need to make sure that you're building the right thing. And you just find out by asking them questions and having a sit down with them. And speaking of inclusion, everyone should participate in defining specifications, and just have people sit down, make them discuss examples, make sure everybody is clear on what they have to do, and only after that begin coding. So in the discussion phase, you should extract functional specifications, which should describe how the system should behave. They should be written from the user's point of view, and from here developers can take it and start a normal test-driven development cycle. I know that myself, I'm thinking from the start at a certain architecture, at a certain design pattern to apply, and this is not quite good for behavior-driven development, and you should keep it as implementation-free as possible, and try to think of it in terms of illustrating behavior, illustrating examples, and so on. The takeaway here is that BDD moves the focus towards the higher level purposes of the product. It's focused on proving your app and making sure that you're building the right thing. Acceptance testing is the building block for behavior-driven development, and you can identify acceptance tests by some specific features. So they're written in a domain-specific language. This means that they're written by domain experts, or at least you should ask them about them when you write them. And they pretty much describe how a user will interact with your app. tests are written in such a manner that they mirror user stories that you created with your client. And the great thing about them is that while you have your business people write them, you can still have developers implement them, and you can get an overview of how much of your software is to be done and how much is complete. So because acceptance testing is performed on the full system, it means that you have to build your app, have it ready. So make sure you have your business requirements nailed down before you begin coding. The good part about this is that you round up your test coverage. You have criteria that everyone can understand, not just developers. And you can ensure that your software as a whole is feature complete. But the bad part is that you're moving up the testing pyramid, so as your tests touch a lot more code, pinning down an error can be more difficult. And you can do acceptance testing combined with UI testing or unit testing, and the final recipe is up to you. You can use it however you like. But what I found to be most useful is to exemplify real cases of how someone would use your app, and to provide some examples of how a user would find your software valuable. And you can have the rest of the validations at class level with unit tests and so on. I know a lot of people don't like unit tests for the reasons I mentioned earlier, but here's where they are important. UI and requirements are going hand in hand, because today you kind of want to deliver functionality as well as experience, and not to mention the device fragmentation is absolutely crazy, and I'm talking Android screens. And you also have to support 2, maybe 3 UI metaphors, so iOS, Android, Windows Phone, and whatever else you'd like. The best time to do tests is when you are developing your application. You get for free regression tests, you can automate them, you can use them in continuous delivery and all that stuff. As I've mentioned earlier, UI tests don't replace unit tests, so you should be doing both. And some specifics about UI tests is that they use an environment that is closest to production, they don't care about system internals, and they run on a simulator or even better on a real device. Okay, so enough talk. I'm going to show you some tools, and hopefully it will work. I have a pre-built app that we're going to let me enlarge this. Scale, yes. Okay, can you see that? I have an app that I already built. It's a simple money transferring and conversion app. So I'll give you a quick example, and then we will start writing tests for it. So let's say I live in Europe, I use euros. I want to send money to my friend in the US. I click on the US button. Let's say I want to give them 50 euros. I get a message, I confirm it, and then I get a receipt. So this is what we're going to be working on. And this is how my solution works. We're going to look at the test projects only, but in your normal workspace, this is how it would look. You'd have a core application, an Android project, an iOS project, and a test project. My test project is a simple NUnit project, And from NuGet, I added an unit. I added SpecFlow to do acceptance tests, and I added Xamarin UI test for the UI testing. I've also added a couple of binaries because, as I said, you need your app to be fully built before you start doing UI tests. And I have an APK for Android, and I've got an IPA file for iOS. Great. And you would normally start by writing a feature, and this is how a feature file looks like. As you can see, it's plain English, so you should be doing this with your whole team. And let's take a look at it. It starts with the feature keyword. You give it a title. My feature is called sending money. Below you can give it a description. And then you start describing a scenario. A scenario is an example of how you would use an app. So for my example, I chose sending local currency to a friend. Now, in order to define this example, I need to give it some steps. And the 3 steps I have represent make up a scenario. So given marks the context in which my test should happen, and my context is given that I have $50 that I want to send to my friend. When should describe the action that I plan to do in order to get to my result, and the action is I confirm the transfer. And then should describe the desired result, and here what I'm trying to achieve is receiving a transfer receipt. So I added this file with SpecFlow, which is available as a Xamarin Studio plugin. And behind the scenes, this created some magic. And then I added another file to implement the steps. So the takeaway here is that I have my 3 steps and written in plain English, and I matched them to these methods. And how do I know that they're linked to each other? You can see here I have a label, and for each label I have a text which is matching my my step. And this is where it gets tricky, but bear with me. Since I'm planning to implement this test as a UI test, I will be using Xamarin UI test. And here I have an interface called iApp, which holds a binary file. And if I'm testing on Android, that's the IPK file. If I'm not, that's the IPA file for iOS. And before every scenario, that's like a setup method in NUnit, I am using, I am newing up my instance, so state from one test won't spill into another. And this is all the setup that I'm doing. I just have one more command here. I'm going to run the test, and we'll figure out what that does. Let's hope it works. So it ran the app, and voila, I get this this REPL, which stands for Read Print Evaluation Loop. And here I can interact live with my UI. I can prototype my tests, and yeah, let's see what happens if I type the tree command quick check of time. Yes, great. So here you can see my screen as a hierarchy. So here you can see the title, so source. You can see the subtitle. You can see the buttons I have. They're implemented as labels here. And what I can do now is tap on some stuff. And app is the iApp interface I showed you earlier, and we can interact with. So to tap on the first button, I would say app.tap and find me the first element, which has the label of EUR. I hope it tapped it. Oh yes, so it did tap it. And to move to the next screen, because it has validation, let's try another label. Okay, so it moved to another screen. And on this screen, I have a text input. And because it has no identifier and no placeholder, I need to find out how to identify that. So I can tap the tree command again. I can see a hierarchy of my page. And I can see here that it's implemented as an entry text edit, and this app is made with Xamarin Forms, so that's why it looks like this. And what I can do is say app.tap again, and if you are using LINQ, you get the same interface here. So you can say element goes to element with a class of entry edit text. It should tap it. Okay, you can see now that it's highlighted. We can enter some text. So app.enter text. Enter text. Say 25. Yes. Right now I'm going to use, again, tap the confirm button, but you can do a lot more. Here you can use swipe gestures, you can use all kinds of stuff. So confirm. No, it kept us. Okay, and I get my validation method, validation message. Now to verify that indeed I've received the confirmation, I can say app.wait for an element with the identifier done. And if it finds it, it will give it back. This is my test pretty much, and what I can do now is copy. It gives me a copy of what I've written, and I can paste it directly into my test. I already have it. Okay, so I'm just going to run the test again. I'll open up the emulator. It should close the app, open it again, and perform the test. And no hands. Yay! I'm always happy when I see tests passing. All right, so if you don't like the REPL, I've got another thing for you. It's called Test Recorder. On the Mac is available as a standalone application. In Visual Studio, you get a plugin. So it's very nice to use. Right now, it boots up my simulator. And it's going to take a while. And from the test recorder, you can send your tests directly to the Xamarin Test Cloud. This is Test Cloud. You can upload your apps here. They will run on hundreds of devices, real devices, and you get back this sort of results. Okay, so now that my app has started, I will click record. I will do mostly the same steps. Let's say not a number, not an umbrella, okay. I confirm, and I can stop it. And the test recorder looks at what I'm doing on the screen, and it tries to guess what I'm doing. And if it gets any of the steps wrong, you can use this Dropbox to correct it. I can run it again to make sure that I tested the right thing, and again, no hands. Come on. Okay, and you can see it's working, it's going through the steps. And what you could also do is click the Output tab. You can copy-paste this output directly into your code. You can have it as a separate C# file. You can just embed it into your project. Or you can send it directly to Test Cloud. And this is all that I've had for today. I will be around today and tomorrow, so if you want to know a bit more about what I told you, I'll be here and gladly answer any questions. Thank you.